Hello friends, welcome back. In this part of video lecture of heat transfer subject, my name is Mr. S. V. Kumar, Assistant Professor, Sharad Institute of Technology, College of Engineering, Yadrao, Ichalkanji. So today we are going to learn how to select heat exchanger for a typical application. The uncertainty in the predictive value of overall heat transfer coefficient can exceed 30%. Thus, it is a natural trend to over-design the heat exchanger. Heat transfer enhancement in heat exchanger is usually accompanied by increased pressure drop and higher pumping power. Therefore, any gain from the enhancement in heat transfer should be weighed against the cost of accompanying pressure drop. Usually, the more viscous fluid is more suitable for shell side, that is for larger passage area and thus lower pressure drop, and the fluid which is having high pressure for tube side. The proper selection of heat exchanger depends on many factors. So first is related to heat transfer rate, whether if we have to extract more energy from hot fluid or medium or low, depending upon heat transfer rate. Second, which is related to cost. Third, pumping power. Fourth, size and weight. Next, type, material. So the rate of heat transfer in any heat exchanger can be calculated by the formula Q is equal to mCp T in minus T out, and the annual cost of electricity associated with the operation of pump and fan can be calculated as operating cost is equal to pumping power in kilowatt multiplied by hours of operation multiplied by unit cost of electricity in rupees. Again, this is dependent on type of heat exchanger, overall heat transfer coefficient, fouling factor. So as I said earlier, the selection of heat exchanger depends on many factors. So first factor is type of duty or heat exchange rate. So this type of duty can be classified as heating of liquids, evaporation and boiling, heating of gas and vapors, cooling of gases and vapors, condensation, cooling of liquids, heating and cooling of slurry. The certain type of equipments are less suitable than other for some of these duties. For example, one example I would like to mention here, for plate and frame heat exchanger, which I had already shown to you, are not particularly suitable for handling gases, but often a heat exchanger is required to perform more than one of these duties. For one of the particular duty where heat exchanger is required to perform more than one of these duty, that is for hot and cold fluid or both. Example is the production of superheated vapor from subcooled state. But sometimes it may be possible to do this in one heat exchanger. At other times, separate heat exchangers might be required for each stage. Different types of heat exchanger may be appropriate for different duties. Next one, temperature and pressure. This is one of the important factor which is required for selection of heat exchanger, where mechanical and material constraint may limit the operating pressure and temperature that can be handled by equipment. In many cases, the two fluids are different. Means through inner side gas is flowing and outer side liquid is flowing, or through inner side liquid is flowing and outer side gas is flowing. Next important factor is material of construction. So material of construction are selected for their combination of corrosion resistance and mechanical strength. For the case of heat exchanger, there is additional requirement of reasonable thermal conductivity, although with exceptions of plastic. This is not usually of great importance. For most of the time, heat exchanger design, we have to choose a material which is not overriding process consideration, but although it may influence the economics. Even if the heat exchanger cannot be fabricated in the cheapest suitable material, there is usually more expensive choice which may still give an acceptable cost reduction. Thus, plate and frame heat exchanger which use sheet of material with no corrosion allowance are not fabricated in carbon steel, but the item cost of stainless steel plate and frame unit is often comparable with that of carbon steel. Also, method of construction, it will also affect on selection of heat exchanger. Next important factor is fouling factor. As I earlier mentioned, fouling factor, generally we need to use river water or sea water in condenser or in cooling tower. When that salty water flows over coil or over metal, it forms a scaling. It deposits over that material, and because of that, extra thermal resistance has to be added which resists heat transfer. So many fluids handled on chemical plants have a tendency to foul heat transfer surfaces. Fouling is more likely in some type of heat exchanger than others. For instance, particulate fouling tends to occur in zones where the velocity is low, such as around the baffles in shell and tube heat exchanger, but fouling may reach an acceptable asymptotic value. But it is desirable to be able to clean the heat transfer surfaces. Some designs can readily be cleaned mechanically. For other, this is not possible and chemical cleaning may be necessary. If the very small passages in a PCHE, that is, it's a closely packed heat exchanger, when it is blocked, even chemical cleaning may not be successful. That's why, in order to minimize fouling factor, we have to select suitable velocity of both the fluids, hot fluid as well as cold fluid. Next important factor which is related to safety and reliability. Safety and reliability is the most important factor which is to be considered while selection of any heat exchanger. So on non-hazardous duties, it may be acceptable to have some risk of equipment failure which would not be acceptable for hazardous duty. For example, with a plate and frame heat exchanger, there is always a possibility of gasket failure, although with correct installation and maintenance this should be low. Such a failure may be an acceptable inconvenience for heat exchanger handling water. It would be unacceptable if fluid were chlorine. So safety and reliability, these are the most important factor. If we are handling hazardous fluid either on tube side or shell side, so safety precaution has to be followed, right? And in case of explosion or in case of leakage, it will definitely hamper the workers. Next important factor is related to repairs. Generally, in case of maintenance or in case of repair, the heat exchanger which is chosen, it should have less number of parts in case of repair. So corrosion or fatigue may put a limit on the acceptable working life of an heat exchanger, but unforeseen plant upsets may lead to premature failure. Some design of heat exchanger can be repaired in an acceptable and economic fashion. One example I would like to mention here, in many type of shell and tube heat exchanger, individual tube which have failed may be replaced, or if this is not possible, plugged with little deterioration in overall performance. Other design of heat exchanger may not facilitate repair and a replacement unit may be required. The likelihood and consequences of failure should be assessed at the selection stage. In case of failure of any component of heat exchanger, it should be repaired in quick time with ease. Otherwise, if in case of failure of one component, the complete shutdown of plant will not be economical, right? So it may take long time and it may arise many problems in power plant. Design method. Generally, we have to design a heat exchanger for a particular application. Well established and proven method exists for thermal and mechanical design of shell and tube heat exchanger. So this is not so for many of the other types, particularly those which can be classified as proprietary design. These often use correlations for the thermal design which have not been published, and for some type of mechanical design does not conform to any recognized code. When purchasing such units, the engineer has to rely to some extent on manufacturer. It is true that all the manufacturers will generally offer a thermal and mechanical guarantee, but their liabilities only cover replacing the unit if it fails to perform. So the method that we are going to adopt while designing heat exchanger, it plays very important role. Simultaneously, thermal and mechanical design has to be considered. One example I would like to mention once again here, when both the fluid flows through shell and tube heat exchanger, those tube sometimes vibrates. That vibrational analysis has to be done in while designing heat exchanger. So design method is also a part of selection of heat exchanger. Dimensions and weight. Okay, this is very important because large size heat exchanger is not preferable in aeroplanes, right? So the installed cost of item is significantly greater than the item cost, typically by a factor about 3. This covers the need to provide pipe work, instruments, foundation, lagging, etc. Many of these are related to either the dimension or weight of the item or both. Considerable saving can be made in the total cost of heat exchanger by the use of compact design. Even if the item cost exceeds that of more conventional heat exchanger, an extreme case, this is the equipment to be used offshore. So dimension and weight plays very important role. One example I would like to mention here once again. If we have to use a heat exchanger, that is condenser, in case of thermal power plant, generally we have to choose shell and tube heat exchanger. Plate type heat exchanger can be used for compact and less weight type application. Cost. Generally, the heat exchanger which should be designed should have low cost. Shell and tube heat exchanger with variety of material construction including graphite tube, air cooled heat exchanger with variety of tube, a plate type heat exchanger with stainless steel, titanium and Hastley plates, cubic graphite block exchanger with phenolic resin impregnation, cylindrical polyblock of graphite heat exchanger with phenolic resin and PTFE impregnation. But the cost plays very important role. More reliable information including data on types of heat exchanger not covered in Nelson index, which can be obtained by consulting manufacturer. The estimation of installed cost can be more evenly difficult, especially if the object is to get a reasonable estimate of the difference in total cost of the two different materials of the heat exchanger for the same duty. So thank you very much.